So as we talked about, the theme of today is big data, machine learning, thoughtful data, right? So like a small story. So I graduated in 97 with Kapil, Kunal from IIT Delhi, worked in India for a year, applied for graduate school. So I applied, and back in the days, there was no internet in India. So you just apply for some colleges and hope someone gives you a fellowship or a scholarship to come to US, because otherwise you cannot pay and afford. So I got few scholarships, and few were in the domain of electronic design automation, CAD, VLSI design, and there was one in computer vision and machine learning. Now, fortunately, in hindsight, unfortunately, at that time, I'm like, the university which is giving me in computer vision machine learning is a good one, but it's not giving me in EDA and computer architecture and VLSI design. So I was so disappointed that I was coming to US to study computer vision machine learning actually. And luckily, fortunately for me, it turned out to be the right thing, right? You never know how things are going to evolve. But if you really think about what happened at that time, why computer vision machine learning was not good, is because, the data or machine learning was going through these cycles. So back in 60s, 70s, 80s, there was a lot of hype about neural networks, big data, machine learning. Things will change. Actually, back in those days, there was no term machine learning. Machine learning was just getting coined. Statistical learning theory was getting coined. People used to call it neural networks in early 90s, and it was considered to be a negative word. Why? Because there was a lot of promise of neural networks, but they didn't deliver. So people are like, we still want to work in the area, but we are going to change the name because we don't want to be known as an AI person. So during my PhD, I could never ever tell anyone that I'm doing AI. No, I don't do AI. I do machine learning. You don't hear that today, right? And what has changed in last 20 years, right? If you really think about it, right? The computational resources and the access to data. And that is one fundamental thing that has changed. So, there have been some advances in algorithms and the way we analyze those things, right? But the basic fundamental thing is now we can just process the more data than we imagined we would ever be able to do that. And while that has led to a number of good things, but there have been associated challenges as well. Rajat and the team have done wonders and kind of changed the industry in some sense, right? Today, pretty much every problem, right? Like you ask any Silicon Valley company and, okay, what do? We use TensorFlow to solve some problem, right? And it's remarkable the way it works, because data, the information is there in the data. So you can just use it and make it work, right? Whether it is a self-driving car, whether you're trying to take the images of cancer, breast cancer, any of those, right? Mammograms, and try to predict whether the person has a cancer or not. Things work. But ultimately it's a data and a machine with only limited understanding. So if your data is wrong, or you're giving it the wrong data, or you're not thinking through what data you're feeding in, your output won't be correct. So a few years back, if some of you guys remember, I think the New York Stock Exchange or NASDAQ had to halt the trading. And what happened was, there were these bots which would go and look at the news websites and based on that do the trading. And Google News was indexing all the news websites, so they were crawling Google News, but they ended up indexing an article which was 2-year-old, some Australian newspaper. So they indexed, everyone thought that something has gone horribly wrong, and the stocks started crashing like anything. So machines, if you don't put enough checks and balances over there, they can actually give you the wrong answer as well, right? Now the scary thing is that with humans, you expect them to make errors. With machines, if they make errors, then you penalize them a lot more, right? That's one. And the second is the actual task that you're using the machines for. You have to really think about that. So one of the problems that we are working on as an example is, can we understand people's career trajectory, how they have moved in their career, to really understand who will be a good fit for which organization at what time. Quite a few times we hear about like, okay, I'm really looking for the top 1% of the people, right? We only hire the very best. But what does that very best mean? Is that person the very best for the role that you are really hiring for at that moment or not, right? And that is really the big question that one needs to ask, right? So actually we do use TensorFlow for that and to predict that. And we have done a number of side-by-sides with humans and found that it works extremely well. So we are able to beat humans meaningfully. And part of his algorithms and part is the data that you feed into it, right? Now, especially now as we start talking about the big data and the kind of problems one is working on, right? I would characterize them into two kind of problems. One is a problem like self-driving car. You let the car run, right? And its system is constantly collecting the data, lane, how other people are driving it, how the traffic is, weather, sunlight, everything. And saying that is the car going to, how should the car drive, right? That's one kind of a setup. But a more interesting, or not the more interesting, but a very other common setup is in your organizations, in whatever function you are looking at some data to make some decisions. And where I have found the biggest challenge is people blindly make decisions sometimes based on the data. So the flip side of the data and the big data, the machine learning and all the smart things is that it is making us lazy. We don't want to think. You start a meeting, you're like, oh, do you guys have enough data? Have you done enough of the customer surveys? What is every customer saying, right? Actually, if you really start thinking about that, then why do you need humans over there, right? Why do you need these good product managers or scientists or anyone, right? Let the data do it, right? But no, you really need to think about the human intuition over there, right? And how it is going to map with the data. Like a very, very simple thing is a causation versus correlation. What is going to cause this thing, right? Is it really a cause, or is it just happen to be there, right? And sometimes teachers don't pay attention to that, right? So one example that Rajat was giving of these nurses and doctors, right? Is that a cause or a correlation? If we just look at the pure data and make that judgment call, like, you know what, if I'm Harvard Medical School, I'm not going to admit females because data says that doctors are males, right? But on the other hand, if I really think about what data is going in, what has happened, how the pattern has been, what was my input set, right? You will come up with a very, very different answer. So in fact, quite a few times I tell my team that data is a cop-out, frankly. And they're like, okay, this is what data is saying. I'm like, I look at the data, first tell me, what do you think? What is your own intuition saying? What are your own hypotheses? And I'm going to validate that with data. And if there's a disconnect, either there's a question with your hypothesis or with the data. And so before VolkScience, I was at Bloomreach in the e-commerce personalization space, right? And we would run these A/B tests with our customers and go through this process and say, so our sales team will constantly come to me and be like, Ashu, it's working or not working, right? And really it would boil down to really taking your hypothesis and intuition and trying to combine it with data. One of the two things is wrong. And quite a few times we don't believe on our own intuition or hypothesis, we just rely on the data. And that's not a good thing. Now, if you were to ask why that is not a good thing, is machine learning wrong? Is the data wrong? No, the answer is not that data is wrong or machine learning is wrong. It's just a limitation of the amount of data that we have access to or the models we are using. And really, if you think about the human intuition, it is really nothing else but an extremely massive data set that it has consumed over the years. And building everything based on that. I have a son who is 4-year-old, right? So I'm just seeing him grow and learn from that. And it's amazing that for the first 2 years of their life, they don't talk much, they don't walk, they don't do anything. They're just sitting over there and just absorbing, right? They're just putting everything in their mouth. And suddenly, you realize one day they started speaking and they're smart. Extremely smart, right? And they can make sentences that you have never ever spoken, right? And that's a data model, really, effectively, right? Brain is the best computer that exists in the world, right? And the data they have collected over 4 years. So, I mean, my take is thoughtful data and big data is really how we are bringing human intuition and insights with the data and have the two play together versus thinking of them in isolation. Thank you, guys.